Bismillahirrahmanirrahim. Diamagnetism on the basis of electron theory. We know that in an atom, electrons revolve in a circular orbit and as such behave as a tiny current loops. And current loops possess magnetic dipole moment, which is given by m is equal to minus e by 2m L, where m is magnetic moment, m is mass of electron, e is the charge on the electron, and L is the angular momentum, which we know is equal to mv or where v is the orbital velocity. So dipole, according to the electronic theory, you see in the figure, we have dipole occur. We have two electrons. They move one in clockwise direction. So with velocity v, I have a mass m. So it is magnetic moment will be opposite to the angular momentum. Angular momentum will be downwards, and magnetic moment will be upward. In case of a electron moving in the anti-clockwise direction, the angular momentum will be directed upwards, and the magnetic moment hence will be downwards. Now, according to electron theory, in diamagnetic substance there are no unpaired electrons in it, and that means all the electrons of an atoms, they are paired. The two electrons of a pair possess orbital motion in opposite direction. If they are paired, so the two electrons, they have velocity in opposite directions. When velocity is in opposite, that means their magnetic moment will be also in opposite direction, but equal but in opposite direction. So the total magnetic moment due to the spin or due to the motion, orbital motion, is zero. So when there is no external field, there is no net magnetic force on the diamagnetic atoms. But when we put this diamagnetic material in an external field, then if Lorentz force F is equal to minus E V cross B acts on the electron. You see the figure, and so this force it will be given. Now the force is V cross B. It is V cross B. So you will see direction V and K. So force will be acting on the electron radially outwards. If the electron is moving in clockwise direction, then the force is radially out, and this force will decrease. This Lorentz force due to the external magnetic field, this will decrease the centripetal force. When the centripetal will decrease, then the velocity of the orbital velocity of the electron decreases, and when the orbital velocity, then by the formula m is equal to minus e by 2m into L. L decreases. When L decreases, so m decreases. That means magnetic dipole moment of the electron decreases. Then on the other hand, if the other electron, which is in the anti-clockwise direction, the central force will be inwards, and in that case the magnetic dipole force and the velocity will increase, and the magnetic dipole will also increase. Hence the net force is not net magnetic dipole on the two paired electrons is not zero. So now there develops a net magnetic dipole moment, which is in the direction opposite to the magnetic field applied, or external magnetic field. So these electrons, thus electron pairs possess some net magnetic dipole moment in the direction opposite to the direction of the applied external magnetic field. Thus the magnetic dipole moments of the pure electrons in all atoms add up to account for the small magnetic movement of the diamagnetic materials in the direction opposite to the action. So this accounts for the diamagnetism of the materials. So 3 pointers you remember. One, that diamagnet on a base of electron theory, diamagnetic have all the atoms are no atom is unpaired and they are paired, and pair electrons they are always in opposite direction. So net magnetic field in the absence of the electric is zero. So diamagnetic, they are magnetic substance have no diameter due to the orbital motion. Second, when they are put into the, so there is a Lorentz force acting on electron. In case of clockwise, it is radially outward, and in clockwise, anti-clockwise, it is radially inwards. In first case, it increases the velocity, orbital velocity, and hence the magnetic moment. And in second case, it in first case it decreases when radially. It decreases the spin angular momentum and hence the magnetic dipole moment. And the anticlockwise, the velocity is increased and hence magnetic dipole moment increases. And in the nutshell, the total moment, this magnetic material possesses a small net magnetic dipole moment which is opposite to the direction of the applied external magnetic field. Thank you.